Welcome back. Today we're going to continue working with slope, and we're going to extend it now to graphing using slope-intercept form. Okay, before we begin, tonight's homework is going to be 2 IXLs, 8.y.5 and 8.y.6. Okay, you can find them linked in today's Google Classroom assignment. We're going to be talking about graphing linear equations today, specifically using slope-intercept form. So you're going to see the real use of slope-intercept form and why it is so important. Before we begin, let's talk about this warm-up where we want to write the slope and the y-intercept of each equation. So first, the slope of this equation is the coefficient of x, which is 8, and the y-intercept, written as b, is the constant, which is -5. Of course, remember, we're already solved. We're in the form y equals mx plus b. We have to be in that form before we write down the slope and the intercept. Here, we are again in slope-intercept form. So the slope is the coefficient of x, which is 9, and the intercept is the constant, which is 3. All right. Now, yesterday we learned how to find the intercepts of a graph. So we take the equation, we replace the x with 0, and that's going to give you the y-intercept. We replace the y with 0 in that same equation, and that's going to give us the x-intercept. Okay? Now, when we do that, we wind up getting 2 points. And what's interesting about having 2 points is any line that passes through 2 points can be drawn. If I have this graph here, and I know that I have a line that passes through this point and this point, I don't need anything else. I know that that line must look like that. Okay? In this case, we have a line, and we know from replacing the x with 0 to find the y-intercept, and then the y with 0 to find the x-intercept. So we found these two intercepts, one being here and one being here. So we now can graph that by drawing a line through the intercepts. All right, so we're going to start with that. And before we start, we already solved for the intercepts of these equations yesterday. When we solved this, we found that this had intercepts at 0, 1 and -2, 0. This had intercepts of 0, 4 and 3, 0. And this had intercepts of 0, -8 and -4, 0. Now, I wrote those down specifically without the graph because I want you to understand that this is the y-intercept and this is the x-intercept, and I don't have to do math to figure that out. I know the y-intercept is whenever x equals 0. Well, this one has an x value of 0, and the x-intercept is whenever y equals 0, so I know that that's the x-intercept and the y-intercept and the x-intercept. All right? So we're actually going to graph these now. So I did these on 3 separate pages, so that way we can do 3 separate graphs, okay? So number 1, we said was the point 0, 1 and -2, 0. All right, so we go to 0, 1 and we put a dot. We go to -2, 0 and we put a dot. And now I just graphed my equation. Number 2, we said had intercepts of 0, 4 and 3, 0. So we go to those points. 0, 4 is here. 3, 0 is here. There we go. We just graphed the equation 4x plus 3y equals 12. And finally, number 3, we said had points of 0, -8 and -4, 0. So 0, -8 is down here, and negative 4, 0 is here. And now we have our graph. Don't forget to put an arrow on both sides because our graph extends in both directions infinitely. Okay? Now, this is where it becomes. This is where slope-intercept form is so useful. I only need 2 points in order to graph a straight line. Any 2 points, right? Now, in the examples above, the 2 points that I had, I calculated the 2 intercepts, okay? But now, I know that this is going to tell me that my slope is negative 5 and my y-intercept is 6. That doesn't tell me 2 points. That tells me 1 point and a slope. But what's great about slope is slope gives you a direction to go from every single point to the next point. So this slope of negative 5 tells me that to get to the next point, from any point, I have to go down 5 and over 1. That's what negative 5 as a slope is. Negative 5 over 1. So the rise is negative 5 and the run is 1. Well, now that's going to help me knowing that I have 1 point. So in order to graph, so I want you to write this down. I'm going all the way to the end, and I'm going to write down graphing slope intercept. So the first thing you're going to do is plot the y-intercept. Then use the slope to plot additional, I'm going to say point or points. You don't have to do more than one, but sometimes the slope is so close to the first point that it's hard without a ruler to draw the straight line. Okay, so we'll show that later on, but I'll just put that there again. So you can pause now if you need to finish writing that in your notes. Graph the slope-intercept form, plot the y-intercept, then use the slope to plot additional points off of that y-intercept. So for this one, if we know the y-intercept is 6, we know that our line passes through the point 0, 6, and knowing that we have a slope of negative 5 means that if I go down 1, 2, 3, 4, 5, and over 1, there we go. Now, all I need are 2 points. I told you that, but again, if I just wanted to make this line just a little bit neater, because I don't have a ruler, I can go down 1, 2, 3, 4, 5 over 1. I can continue to do this just to find additional points, just because it would help me. 1, 2, 3, 4, 5 over 1, just because it will help me when I'm lining it up. I only need 2 points, but again, without having a ruler and trying to do this on my computer screen, it's just nice to have the additional points, so that way it helps me draw that line. Okay? Number 2, here we have a slope of 3 and a y-intercept of negative 2. So that means we know our graph passes through this point, and we know a slope of 3 means up 1, 2, 3 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1, or, now remember, rise over run, a positive 3 could also be a negative 3 over a negative 1, so it could be down 1, 2, 3, backward 1, and you notice how we're still falling 1, 2, 3, backward 1, we're still falling in that same straight line. That was terrible that I just did, okay? But that is how we graph in slope-intercept form. That's why slope-intercept form is so great, because we don't need anything other than our knowledge of what slope-intercept form means in order to graph a line. Here, I chose this one specifically because we have a slope of 7, but what's our y-intercept? It would be our constant. it's non-existent, right? Well, that's okay. It means that our y-intercept is 0. So that means that our y-intercept is 0, 0, slope of 7, 1, 2, 3, 4, 5, 6, 7 over 1. Or we could also go backward, go down 1, 2, 3, 4, 5, 6, 7, backward 1, because that's negative 7 over negative 1, which is positive. And now I have my line, and now I just graph that. And then finally, number 8, I chose this one because I want you to see this is a slope of negative 1 because that's what the coefficient is, and a y-intercept of 6, which means we go through here, we go down 1 over 1. This is why I plot additional points usually, because I could certainly say, all right, it goes like that, but just plotting down 1 over 1 additional points allows me to make this graph much more accurate. And there we go. And that's how we graph that equation, okay? Now, yesterday, we turned all 4 of these into slope-intercept form already, okay? So I just wanted to review that. This, we got y equals 1/3 x. This, we solved and got y equals 3x minus 14. This one, we solved to be y equals 1/4 x minus 4. And this one we solved to be y equals negative 1/4 x plus 3. So for this one, I'm going to go through the point 0, 0 because this has a slope of 1/3, but a y-intercept of 0. So it passes through the origin, and a slope of 1/3 means rise 1, run 1, 2, 3. Rise 1, 1, 2, 3. 1, 1, 2, 3. And that's what that one looks like. This one, unfortunately, the second one, we can't put on the graph that I have here because I don't have a negative 14. Okay, it only goes down to negative 8. There are other ways to graph that, such as using intercepts if we wanted to, or no, because we can't put the intercept there. But we can try to find different points on our graph, but I'm not gonna go over that too much. I'm not gonna go over that today because I don't think that it's that necessary. This one, our y-intercept is negative 4, so we go through negative 4, and our slope is 1/4. So 1, 2, 1, 2, 3, 4. Up 1 over 1, 2, 3, 4. See that rise over run? Or positive 1/4 is also negative 1 over negative 1, 2, 3, 4. And you see how it still lines up on that straight line. If I went down 1, 1, 2, 3, 4, again, the more points you have, the more accurate it's going to be. And then finally, the last one that we're going to do today, we'll choose a different color. And I didn't choose a different color, did I? Okay, there we go. And this one right here, we have an intercept of 3 and a slope of negative 1/4, which means we go down 1 over a positive 1, 2, 3, 4, down 1 over a positive 1, 2, 3, 4, or up 1, but backward, which is negative 1, 2, 3, 4. Again, the up one is positive, but the backward is negative, and we're falling into the same line, and now that's how we graph slope-intercept form. Okay. If you have any questions, email me, but don't forget to do your 2 IXLs today. Slope-intercept form, plot your intercept, your B value. That's where your line crosses your y-intercept. Then from that point, use your slope to find additional points. You only need to find one additional point, but finding more additional points just makes your graph a little more accurate if you don't have a ruler. Okay? Have a wonderful day, and I will see you live tomorrow. We'll have our Google Meet lesson, so I look forward to seeing you all tomorrow. Okay, goodbye.